continuing with my previous video where I took up the topic of NumPy, which is numerical Python, I would continue with 2D arrays, stacking, reshaping, and much more. So, without uh, wasting any more time, let's get started with the coding part. So, here is it. Let's start with a stacking example. So, let me just copy. Okay, so here we go. We have got 2D arrays. In the previous one, we covered the 1D arrays and various operations on them. So here we have got 2D arrays and we would focus on them. And first of all, we have the NumPy stack example where we first of all import the NumPy package. So the statement goes as import NumPy as NP. Then we define two arrays. The first one is array 1, which has elements 55, 200 and 350. The array 2 has elements 14, 96 and 500. So we would display both of the arrays, then we would call the stack function and then see what is the output. So we can use the execute button here, or we can select it all and run control plus enter. So I'm just doing that. Let's wait some time. Okay, so here we get the result. I had to do one minor change. Both the arrays for input for stacking, they should have the same size. So in the second array, I had given one element less. So now you can see the first array displays, we have got elements 55, 100, 200 and 350. And in the second array, we get the displays 14, 96, 500 and 700. The output of the stack that we get, you can see the one, it looks like one on the top. So we have a stack formation here where we see the array 1 elements here and then the array 2 elements, and you can see this bracket comes, we have a starting bracket, then another bracket, then the first array, the bracket closes, then the bracket opens again and we have the second array and then the bracket closes. So this is a stack, and it can have certain utilities, maybe for display of certain elements in a quantitative list, or maybe we need to explore that. Maybe we can figure out some practical examples. Okay, so let's move forward. So now I would take two examples of array reshaping. So what we mean by array reshaping is that we uh, change or transform the shape from one type of array to another. So we have an example where we in fact more than one example where we would change from 1D array to 2D array. Okay, so let's first start. We have an array defined as 6 elements. So it's kind of a table, first 6 elements of table of 11. Then we reshape this array to a 2D array. So we have the parameters 2 comma 3. So 2 would be the number of rows and 3 would be the number of columns. Let's see how it goes. So we would run this whole. Okay, so here we get to see, first we print the input array. which spans from 1122 onwards to 66. Then we see it has been reshapen. Okay, I think there has been some. Let me just clear and run again, because I think the output of the first run was there. Oh, I think we have to. Okay, so maybe cannot remove it. So you can see it here is the input one, and then it has been transformed to an to a 2D array where we have 11, 22, and 33 in the first row, and 44, 55, and 66 in the second one. And these 100, 200 are coming from our previous one. So okay, I think let me just run it again with some changes. Just for a moment. I think it executes the complete input, not just the selected one. Now we run it again. Okay, so here is the clear output. You can see the 6 elements at the top. Then these have been transformed from 1D array to 2D array. So we can see 11, 22, and 33, and 44, 50, and 66. And another lesson learned that if you are executing something through Google Colab, and maybe I think through Google through the Python IDE also. So if you have a complete text and you just want to run execute a selected one, then comment out the one that you do not want to execute. So let's now uncomment the lower part and see what output we get. So here we have a third parameter -1. So I am not too clear why this. So maybe I would need to check a bit. If you can, you may answer this in the comments, or I can share it later on. Okay, so let's run this one. Okay, so we have a another 1D input array. So we have random elements. So first we have a increasing series from 100 to 900 with a gap of 100. Then we have three more elements, 1200, 1500, and 1800. Now we pass the function array.reshape, and the first two inputs are 2 comma 3, and the third one is -1. So okay, I can see it has transformed this into a kind of a 3D array with a third parameter being passed, but I need to get a little more clarity on this, because the new shape it's giving us 2 comma 3 comma 2. So that means it's the third dimension is 2. Then we have two rows and three sorry, it's two columns and three rows in fact. So I think the -1 could be transposing the columns and rows. So we'll check it out and let you know. But here is the transformation. So you can see these are the elements. We have okay, I think its alternate elements are in the column. So we have 100, 300, 500, 700, 900, and 1500. Then we have 200, 400, 600, 800, 1200, 1800 in the another column. So I think that's kind of a transposing effect it has given, and the alternate elements are picked up. So maybe we can play around with them a bit, but just make sure that the it caters to the these two and three, these parameters are in the multiples of what is being passed. Because otherwise, if suppose I pass another element, I'm not sure if I will get a correct result. Let's see. Okay, it okay. The issue is that the input array was of size 13, so it cannot be broken down into an even parameter. So here it's not in the multiple of 2 and 3 or any similar thing. So it cannot handle it. Maybe if we add a few more elements, make it 16, then it should work. Now one more. So just some random element. Let's see if it works for us or if we need to make some changes. I think we have got another error. Maybe let's try with 4 here and see if it can work. Otherwise, I think we'll need to explore a bit more and maybe come up with. Okay, I think here is the key. So we have 2 into 4. I think something multiple. So 2, 4, 2. Okay. So that makes it 2 into 4 into 2. So it's a transformation to a 3D array. And I cannot make out why this minus 1 is here. It should have, it, maybe we could have passed 2, 4, 2. Maybe you can see what's the result in that case. No, whether it runs or not. So this is another way. Maybe you might have preferred that I would have shown you everything in the correct way, but running this way is another learning so that we can see what error comes. And what is the good part is the Python compiler has a good error handling mechanism, and it shows the, it points out where is the error and almost the error itself, what is the error. So that way we can just quickly figure out that what we have mistyped or what is that we are missing, and then we can correct. So now let's run it. Okay, so it works. It's a direct way, and we'll need to figure out what's minus 1 for. If you know about it, maybe you can share in the comments. Otherwise, I will just take some time and get back to you. Okay, let's move forward and see about adding of arrays. There was one more thing about flattening of the arrays. I would cover that in some later video. So that is a reverse of shifting from 1D to 2D array. It's kind of, it moves the arrays from 2D, two-dimensional to one-dimensional, or maybe we can bring them back from nth dimension, maybe 3, 4, 5 dimension to 1 or 2 dimension. So we have this utility NumPy. Here we can add two arrays. So why is the need for adding two arrays? So you can think like this, that suppose we have a list of certain scores in a certain subject from two different colleges, and we need to either add them or maybe we need to do some sort of comparison or difference, and we can do this through a list, or we can use the NumPy array. Now the advantage of using NumPy is that it is computationally less intensive, uses less memory, and is fast also. And with list or other structures, we need to write more code. In Python, the code is not too much, but still any additional line of code takes time, space, and memory. So here is the example. We have first input array A, which has got three elements. So we have got elements 10, 2, and 23. Then we have the second array, which is two-dimensional, and uh, it's it has got elements 24, 58, 60, and 72, 18, 39. So this is the first row of 24, 58, and 60, and this is the second row with three columns. And now we want to add these two arrays. Now the first question that could come to your mind is that if these are of dissimilar size, not of the same size, then how would we be adding these? The answer is that uh, NumPy performs an operation known as broadcasting, where it automatically converts array from one type to match with array of another type so as to bring at the same level. So in this case, what it will do, it will transform the first 1D array to a 2D array. And the way is simple. It will just put in zeros to kind of fill those positions. So let's see how it works in practice. I will just copy this code and let's run in the Google Colab. I will delete these comments as well. Okay, so now let's run these. Okay, the import command is very important, otherwise the compiler might fail. Let's run this. Sorry guys, I have a relatively new mouse and sometimes it needs harder. So you can see the first matrix is printed as below: 10, 2 and 23. And then we have the second matrix. The first row is 24, 58 and 60, and it has shape 2, 3, so 2 rows and 3 columns. And then we have got 72, 18 and 39. Then we need to find out the sum. So we get the sum as 34, 60, 83 and 82, 20, 62. So how is this going? You can see the first element in the first matrix is 10 and in the second it's 24. So 10 plus 24. So the first element adds up to the first one and we see the output as 34. Next we got the second element as 2, and in the second matrix the second element is 58. So to sum them up we get 60, and so on for the third one we got 83. And now if we come to the second row of the second matrix, it will add up with 10, the first element, 10 plus 72. So maybe I can just write it down. So 10 plus 72 equal to 82. Now we have got 2. To 2 we add 18, which is here. So we get 20, and then we got 23 plus 39, which makes it 62. So we get these results. This is a good mechanism, and maybe in some of my coming videos I would myself like to explore how we can come up with differences, the subtraction part, multiplication and division. So in division, of course, we might have to write some check for 0 division by 0, but the multiplication and subtraction would be quite interesting. So I think if you have studied about kind of matrices in higher classes in your mathematics, there this kind of an arrangement could be very handsome, because that would mean that we can efficiently add, multiply, subtract big elements, and even I think it could work on the floats or doubles where we have the decimal parts. So just imagine that if you can write a program to solve those matrix problems, it could be very handy. And I think that is the strong part of Python, that it provides libraries and packages to do such kind of routine things very fast. And not just routine, as we move forward, we would see it used not only in statistics but in many more uh, domains of data science and engineering. It comes in very, very handy. So, here I would just end this part in this video. I hope you liked the content, and more than that, you would find it quite useful. And I would try to bring in more and more content. The Python part would go on for quite a long time. I would like to know your opinion, how you found the part so far, and what all topics would you like me to cover in Python? I would, of course, be bringing more about NumPy and then other packages and libraries. And you can share your general feedback your comments. They mean a lot to us, and I hope uh, it would be useful for you in your tech journey. So have a nice time. Bye bye.